Stars destroying each other, black holes swallowing entire solar systems, galaxies colliding. Our universe is in a constant state of motion, all driven by the unstoppable force of gravity. Most orbits out there are deadly. Unlike our orbit perfectly placed in the Goldilocks zone, if it were to drift even slightly towards the sun, our oceans would boil, potentially turning Earth into a second Venus. Conversely, if it were to drift slightly farther away from the sun, we would freeze into a snowball Earth. It's not just about the position. Our planet also orbits in an almost perfect circle around the sun, unlike other planets. This means the entire orbit is quite stable with minimal dramatic changes. That raised the question, is this orbit typical throughout the universe? As the scientists delved deeper into the cosmos, what they discovered was far beyond anything anyone could imagine. Even within our own solar system, we see hints of orbital instability. Mercury, the closest planet to the sun, has a particularly eccentric orbit. Its path around the sun is more elliptical than circular. This means its distance from the sun varies significantly throughout its orbit. Its farthest point in its orbit is nearly twice as distant from the sun. If Earth's orbit were to exhibit similar behavior, even within its cozy Goldilocks zone, sustaining life would likely be impossible. The Earth's orbit generates seasonal weather changes and temperature differences of dozens of degrees, while with an orbit like Mercury's, you would experience much more drastic temperature fluctuations throughout the year. The temperature difference is so extreme that Earth could lose its entire atmosphere, with temperatures reaching extreme highs when it's closest, and plummeting to extreme lows when it's farthest from the sun. Mercury's eccentric orbit is thought to be influenced by the gravitational pull of the other planets in the solar system, particularly Jupiter. This gravitational tug-of-war creates perturbations in Mercury's orbit, causing it to deviate from a perfect circle. These perturbations, while seemingly small, can have significant effects over astronomical timescales. In the distant future, there's a small possibility that Mercury's chaotic orbit could elongate to the point of intersecting with Earth's orbit, posing a potential ominous threat. Computer simulations indicate that there's roughly a 1% chance of Mercury to end up in 3 terrifying scenarios. First, being ejected from the solar system, turning into a rogue planet. This occurrence is not unheard of in our cosmos, with planets being expelled from their orbits and left to drift alone in space. Another potential outcome for Mercury is a collision with the Sun, but the most catastrophic scenario would involve a collision with a neighboring planet. And yes, it includes Earth, but don't get too uncomfortable just yet. We are discussing a 1% scenario that, if it were to occur, would unfold over billions of years. This insight, however, reminds us of how lucky we are. Not all celestial objects share that luck. This chaos is amplified as we venture beyond our solar system, where gravitational forces can tear apart planets. In this vast cosmos, you might assume that there are numerous Earth-like planets with stable orbits, but that assumption would be wrong. Scientists were hopeful of discovering Earth-like planets with stable orbits, but the search proved to be more challenging than anticipated. The orbits of these exoplanets were far from what anyone could have expected. The discovery of exoplanets has revolutionized our understanding of planetary systems. It revealed the incredible diversity and chaotic nature of planetary orbits. Many exoplanets, Jupiter-like, orbit incredibly close to their stars. These gas giants experience intense heat and radiation. Some of these exoplanets orbit so closely to their stars that it takes them mere hours to complete a full orbit, a revelation that came as a significant surprise to our scientists. Not only was their existence unexpected, but it also appears to be a common occurrence for a solar system to have a Jupiter-sized planet in such close proximity to its star, a phenomenon we refer to as hot Jupiters. We began to uncover extreme orbits that were not limited to planets. Rather, they had the potential to disrupt and even shred stars. While our Sun is a solitary star, many stars exist in binary or multiple star systems. These systems can be incredibly chaotic, with stars locked in a gravitational dance that can have catastrophic consequences. Binary stars, 2 stars orbiting a common center of mass, are quite common. When these stars are close enough, their gravitational fields can interact in extreme ways. These interactions can distort the stars themselves, pulling them into elongated shapes. In some cases, the gravitational pull of one star can strip material from its companion. It can often turn into a violent collision with devastating effects on any planets unfortunate enough to be caught in the crossfire. Imagine the orbit of a planet with 2 or 3 suns, their gravitational dance far from the stability of our own solar system. Many of these unfortunate planets pushed away from their solar systems become forever alone as rogue planets. Or even worse, they fall victim to one of their own stars. But those stars themselves are not safe either. 16,000 light-years from Earth, there's a binary star named HM Cancri, which contains 2 white dwarfs, very dense small stars. These 2 stars are so close to each other that they are 5 times closer than the distance between the Earth and the Moon. They orbit each other so closely and rapidly that they complete one orbit in about 5 minutes, a speed rarely seen in space. Scientists believe that their violent orbit disturbs the fabric of space, generating gravity waves. It's only a matter of time until they collide, ending their cosmic dance in a massive supernova explosion. The most extreme examples of binary star interactions involve incredibly dense objects like neutron stars or black holes. These remnants of massive stars possess immense gravitational pull, warping the fabric of space-time itself. When these objects are locked in a binary system, their dance can shake the very foundations of the universe. As these massive objects spiral closer and closer, they emit gravitational waves, ripples in the fabric of space-time that travel at the speed of light. These waves carry away energy, causing the objects to spiral even closer until they eventually collide in a cataclysmic event. These collisions are some of the most energetic events in the universe. They release immense amounts of energy, briefly outshining entire galaxies. We have discovered planets orbiting pulsars and planets orbiting black holes. And here we are in our pleasantly calm, quiet, and peaceful cosmic neighborhood. Earth's stability is a rare and precious thing. We are not subject to extreme gravitational forces. This stability has allowed life to evolve over billions of years. Stability, liquid water, and a protective atmosphere make Earth perfect for life. Earth is a rare jewel, a testament to the delicate balance required for life. A true miracle. And we are fortunate to have such a stable and peaceful orbit. These orbits, shaped by gravity, profoundly impact our entire universe. As we peacefully orbit the Sun, our solar system also orbits around a massive black hole alongside numerous other solar systems, thus forming our galaxy, the Milky Way. As galaxies around us collide and intertwine, creating a network of galaxies that constitutes the largest structure in our entire universe. Perhaps one day, we will unravel the mystery of what our universe itself orbits. Until then, join us in exploring the extreme exoplanets from a closer look.